All right, so we're gonna review energy now. So this is the first learning target for energy. It just says I can explain what different types of energy exist in a system. So before we even go to the different types of energy, we want to know the definition of energy in general. So I have it over here. It's a conserved substance-like quantity that has the ability to transform in a system. What you need to pay attention to is the fact that it's a number. That's what this means. Okay, it has a value. Has a numerical value, and also it is conserved. Which means that in order for it to be conserved, it has to transform from one type to another. So that's the definition. How is energy measured? Its unit is the joule, so it's a capital J. Let me spell like that. Alrighty. Okay, so let's go into the different types of energy. First category of energy is potential energy. This type of energy is stored in a system. So it's like stored, and then you can do things with that stored energy later on. So there's three major types of potential energy that we're going to review. The first one is gravitational potential energy. That's the energy that an object has due to its position. And the key word that you want to pay attention to see if something has gravitational potential energy is if something has height. So when you're reading a practice problem and it gives you a height of some kind of value, then you know the object has gravitational potential energy. Okay? The next type of potential energy is elastic potential energy, and that's energy stored in the deformation of an object, and the object has to be elastic because that means it can be deformed. When it means it's being deformed, it means that its original shape is changed, and what the object wants to do is return to its original shape. Okay? How do you know it's being deformed? When you're reading a problem, if you see the word deformation, or you can visualize that an object's being deformed, or if you see the word that something's being stretched or compressed, that's when you know elastic potential energy exists for that object. So it will have some kind of displacement. That's going to be the amount of stretch or compression. And then you'll often get the spring constant value as well, but we'll talk about that in the next learning target. The last kind of potential energy is chemical potential energy. That is the energy that's stored in the bonds of a molecule. So you might have learned about this in chemistry, but in order to form a bond, you have to put energy inside of that bond, and that's why energy is stored within the bond. Okay? In order to build a bigger molecule, you have to input energy, and the energy again is stored within the bond that holds those atoms together. Now, the opposite is true. So when you break the bond, energy is released from the molecule, and that energy can be used to do things with it. We'll talk about work at the end of the lesson. It's like one of the last learning targets. Okay, the second category of energy is kinetic energy, and that is the energy an object has due to its motion. So the key word for kinetic is something is in motion, something has movement, something has a velocity. Anytime an object has velocity, it has kinetic energy. For our class, when you're calculating, it's just going to be kinetic energy in general. You don't need to calculate the specific types, but if you're identifying different types of energy within like a diagram, then you'll want to know these different types. So one type of kinetic energy is thermal energy. It exists when atoms are just moving in general. That generates a lot of heat. Okay, so when atoms move and they vibrate, it releases thermal energy, and that is another term for heat. Another type of kinetic energy is radiant energy. So this is not moving electromagnetic waves, because electromagnetic waves are light, and they actually do move. And when they are moving, obviously, they have kinetic energy. Sound energy is a mechanical wave that exists in the vibrations of the molecules in the air. So when you speak, you actually are vibrating the air molecules around you, and that creates sound. Okay, we'll talk about that in the unit on waves. And then finally, a specific type of kinetic energy is rotational energy, and that's just specifically an object's rotating. The motion is just a rotational motion, and it's just rotational kinetic energy. So that's it. There's other types of energy down here. So there's electrical or electric energy. They're the same thing. I put in other types because it doesn't really fall into kinetic or potential. They have both of the versions. So the potential form of electrical energy is electrons stored in a battery. When they're in a battery, they have the potential to do work and to move, but when they're just in the battery, they're not doing anything until you actually complete a circuit, and then those electrons can start to flow. Once those electrons are actually flowing within that circuit, then you get kinetic electric energy because the electrons are actually moving and allowing for the whatever the device is to work. There's also electromagnetic energy. So this one also has two forms. It has potential and kinetic. This is focused more on the magnetic side of electromagnetism. So the potential version of it is you have a metal object that can be magnetized, but currently is not. And then once the object has been magnetized, then magnets, they exert a field, a magnetic field, and they attract or repel each other, which causes movement, okay? So that's why electric and electromagnetic energy, they have both versions. They have a potential version where something is just stored, nothing's happening yet, there's a potential to do something, versus a kinetic version where there's actually movement of electrons or movement of magnets toward each other or away. And then finally, energy can also be dissipated. This is just the form of energy that is lost and can no longer be used. Most often, this would be in the form of heat or thermal energy being lost because of friction. And again, friction is when there's two objects and their surfaces are, in contact, and there's resistance to an object's motion, and that causes friction to exist. So now that we've gone through every single type of energy, we can apply it to this example below and just label the types of energy that are present in this diagram. So what I'm going to do is we're just going to go in order. Here is a coal power plant, and we have air moving toward the pulverized coal, and that actually heats it up in the boiler. The boiler's job is then to convert the water from the condenser into steam, and the steam is moving toward the steam turbine. The turbine will turn, which will in turn turn the generator, and the generator is going to be the one that emits that electricity or creates that electricity. We also see there's a stack, and in the stack, combustion gases are being released. So let's just start from the bottom, just sequentially. So we have air moving toward the pulverized coal. The reason the coal can actually heat up the boiler is because it has energy stored in its bonds. So that is going to be chemical potential energy. I'm just going to write P for potential energy. Okay? Then in the boiler, we have heat. Heat is associated with thermal energy. And that heat is going to be heating up the water, which is moving up and becoming steam. So the water is moving, which means it has, so I'm just going to actually label this entire section. Because the water is moving, it has kinetic energy, but as it moves up, it's going to be gaining gravitational potential energy. Okay, so I have there kinetic energy and gravitational potential energy, which increases as the water moves up. Then we have the steam moving toward the steam turbine, and as you know, the steam turbine, it rotates. So in the steam turbine, we have rotational kinetic energy. Generator is something we're going to return to in a later unit on electromagnetism. But all you need to know right now is when the steam turbine rotates, it also rotates something within the generator, and the generator in turn is going to create our electrical energy. So I'm going to say electric energy. All right. The last thing is you want to look at the stack. So a lot of power plants are not entirely efficient, which is something we'll chat about later on too. But this demonstrates why it's not efficient. There's energy that is lost in the process of creating electricity. So the stack over here represents the dissipated energy. The boiler creates a lot of heat, but not all the heat is actually going to be used to convert the water into the steam. Some of it is just lost to the environment. And as you can probably expect, there's lots of areas in between, like in this power plant that are not entirely efficient as well, not just within the stack, but you can think like the steam turbine, when it's rotating, maybe there's some friction there as it's going through the motion. Maybe in the generator, there's not as efficient or smooth processes. So there's a lot of loss of energy in every single step. So one challenge is how do you minimize the loss of energy within these types of systems. So that's it for the first learning target, and then we're going to move on to the next one, which we're getting into the equations for the types of energy.